let's revisit example number 1. Let's write an equation for the amount of water that's in the pool at any time. I know in the first example it was a matter of how much water is in the pool at the end of the party. But let's write an equation for how much water is in the pool for any time. Let's call it P of T for pool. So we got pool, there we go, P of T. All right, so again, based off of what we just talked about in the previous section, in that previous video, we are looking for an initial condition, all right, and that initial condition is 2,000 gallons of water. And we're going to add to it all of the positive change. Now we saw that there were it was an 8-hour pool party, 5 gallons per hour were leaving the pool, but 2 gallons per hour were entering the pool from a garden hose. All right, so we're going to have the integral from the start of the day, which is at 0, to whatever time we want, t rather, and the rate is 2. So we'll have 2, and then we have to use a different variable, so we'll just go 2 dx for our differential right there. And then we're going to subtract all the water that's leaving the pool. And the amount of water that's leaving the pool, we see there is 5 gallons per hour. So that's our exit rate. So we'll have minus the integral from 0 to t, because again, we're starting at time 0, we're going to whatever time we want, and it's 5 dx. All right, and so this equation right here will give us the amount of water at any time. So for example, if we want P of, P of 8, it was an 8-hour pool party. All right, well then we would do 2,000 plus the integral from 0 to 8 of 2 dx minus the integral from 0 to 8 of 5 dx. So that would be 2,000. And then this integral right here, this would become 2x if we antiderive it. And it's being evaluated from 0 to 8. But it's good when we plug in 0 because we're not going to get any value for that. When we plug in 8, we'll get 16. And then right here, this becomes 5x, also being evaluated from 0 to 8. So that gives us our minus 40. So we end up having 2,000 plus 16 minus 40, or it brings us down to the 1976 that you got as your answer the first time around. Right? So there's our equation in action. Right? We do the same thing for example 2. Right? We had 1,250 people at the island resort at the start of the day. Right? So we'll just call it I of t for island. All right, I of t. All right, so we have 1,250. That's our initial value. Plus, and then we're starting at 9 a.m. So that's going to be our integral. Lower value, 9 to whatever t we're looking for. And boats are bringing people in at a rate of 150 per hour and then departing at 125 people per hour. So plus 150 dx, because again this variable should be different than that one, minus the integral from 9 to t of 125 dx. All right, so there's our equation. And again, if we were interested in the amount of people at 5 p.m., well, 5 p.m. is actually going to, if 9, so 12, obviously noon would be 12, 1 would have to be 13, 2, 14, 3, 15, 4, 16, and 5 is 17 hours into the day. Think military time. So I of 17 would be 1250 plus the integral from 9 to 17 of 150 minus the integral from 9 to 17 of 125. All right, and oops, I forgot my dx's. All right. Now the quick way to solve these integrals is you do, because there's a constant right here, you do the constant times the difference of the two bounds. All right, so this is going to be 1250 plus 150 times 8 minus 125 times 8. Now 125 times 8 is actually 1,000, and 150 times 8 turns out to be 1,200. oops, comma's wrong spot. There we go. So we have 1250 plus 1200 minus 1000, or 1450. That would be our total amount of people that are on the island at 5 o'clock.